Hi everyone, welcome to the Dataholics YouTube channel. And in this video, we are going to understand the concept of recursion in Python, right? But before exactly understanding what is recursion, when do we use it, why do we use it, we will try to understand about nested functions in Python, right? So what are nested function? Nested function means a function inside another function. Like we have seen about nested if inside another if. Similarly, function inside another function will be called as a nested function, right? So it is a very simple example. Define function f. I'm creating a function called f, and inside the function I'm printing inside f. Then I'm creating another function called g inside f, which is printing inside g. Correct? And after creating the function g inside the function f, I am calling the function g. Right? I hope you're able to understand the structure. So in nutshell, the function f does three things. First, it prints inside f, then it creates function g, and then it calls function g. These are the three tasks done inside the function f, right? And then I'm calling the function f. What happens? Let me execute. It is printing inside f inside g. Why? Because when I call function f, it will go to here and it will print inside f. That is why this line is printed, right? Then it will create the function g and nothing will happen. But then it is also calling function g. And since it calls function g, it will go up again and print inside g, and that is why this line is printed, right? To better understand this visualization of nested function, I'll take you here. Okay, yeah, we already have the code here in Python tutor, visualize execution. So now see, next. So first the function f is created in the global frame. See, function f is created. Then next, I'm calling the function f in line number 8. Next. So when we call it, the cursor jumps to line number 1 again, and it will come inside the function print inside f, right? Then it will go here, create function g. See, the g is also created here, and the parent of g is f1. F1 means f. See, f1 means f because g is created inside function f, right? And that is why it is printing. And then when we call g, it is printing inside g, and that is why this line 2 is printed, right? I hope now you are able to understand the execution of this and just a glimpse we have got about nested function in Python, right? So another format of nested function is recursion. Recursion means whenever we call the same function inside itself. So, okay, let us not confuse each other. So next, recursion is nothing but when we call a function inside itself, it is called recursion. Okay. So for an example, I will give you an example of factorial. So let me use the notebook and help you understand recursion in Python. Right. So basically, when a function calls itself, the concept is called recursion. Example, let me first give you a logic and then we will understand how do we incorporate recursion in it. So we will try to create a program for factorial. Let us first understand what is factorial for those who don't know. And those who know what is factorial and how do we create a program, you can skip this part of the video, right? So factorial is nothing but, like, for example, if you have to calculate 5 factorial, so it will be 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1, right? So this is nothing but calculation of factorial. If we have to create 10 factorial, it will be 10 multiplied by 9 multiplied by 8 multiplied by 7 multiplied by 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. Now what do you think? Can we write 10 factorial as 10 multiplied by 9 multiplied by 8 multiplied by 7 multiplied by 6 multiplied by 5 factorial? Both are same things because 5 factorial is nothing but this much. This much is nothing but 5 factorial. So I replaced it with 5 factorial, right? Similarly, understand 5 factorial can be written as 5 multiplied by 4 factorial, right? So this is just shorthand, right? And now let us create a function in Python to calculate factorial without recursion, because we need to understand the absolute logic and then how do we incorporate recursion in it. So define factorial. I always try to write code here in the notebook so that we do manually and we understand the execution, we understand the logic, right? So please be with me here. Then we will see in the code itself. Define factorial, and I'm passing a parameter called n. Inside it, I will create a for loop, or instead I can create a while loop, which will be much easier. While I is less than, hold on, while I is greater than equal to n. No. N is greater than equal to I actually. While 5, okay, so 5 should be greater than equal to 1. Okay, so this will be the logic. While n is greater than equal to 1, right, colon, and we will say fact is equal to, we will create a variable called fact multiplied by n, right? And here inside, above it, we will create a function called, variable called fact, and the value of fact initially will be 1. So now, and we have to, okay, decrease I is equal, n is equal to n minus 1. Now, yeah, this is inside the while loop. Once we come out of the for while loop, we will say print fact. This will give the factorial value. For an example, how does this function execute? Let's say I call this function fact with a value called 5. So inside this function, what will happen? Fact will become 1. This is the new variable. While n is greater than equal to 1, that means 5 is greater than equal to 1. True. It will come inside the for loop and execute this much, 2 lines. So it will say fact is equal to fact, which is 1 multiplied by 5. That means fact will become 5. And n is equal to n, that is 5 minus 1, that is 4. After first iteration, these will be the updated values of fact and n. Then again, it will go up to the while loop, and the value of n is now 4. So the logic will be 4 is greater than equal to 1. Condition true. So it will say fact is equal to 5, current value of fact, multiplied by n. No. Yeah, current value of fact is 5 multiplied by n. N is 4. 5 into 4. And then n is equal to n minus 1. That is 3 now. Similarly, the next value of n will be 3. So 3 is greater than equal to 1. Condition true. Fact is equal to 5 into 4 into n. N is 3. And n is equal to n minus 1, which is 3 minus 1, 2. Right? I hope you are able to understand the execution. 3 minus 1. 1 equals to 2, right? I hope you're able to understand. Now, since similarly 5 into 4 into 3 into 2 into 1, which will help us to calculate factorial and store in the variable called fact. And then that is exactly what we are printing here outside the while, right? So this is nothing but a function to create, to calculate factorial in Python. Let me show you. Yeah, see, define factorial n, fact is equal to 1, while n is greater than equal to 1. Fact is equal to fact multiplied by n is equal to n minus 1, and return fact. I hope now you are able to understand the flow logic behind factorial, and I can call this function with any value, like 5 factorial of, let's say, 5. So factorial of 5 is 120. Yeah, it is absolutely correct. If multiplied by factorial of 6 multiplied by 6 will be 56. It is a very large number. 720. Awesome, right? So this function is working fine. But this function can be created with recursion. How? Let me show you. See, define factorial n. If n is equal to 0 or 1, then return 1. Because mathematically we say that if we are calculating the factorial of 0 or 1, it is 1. This is the truth. There is no logic in it. It is the rule, right? But else, if the value of n is not 0 or 1, then we will say return n multiplied by factorial of n minus 1. Just imagine, this is nothing but it is like this. Like if I want to calculate the factorial of 5, it is 5 multiplied by factorial of 4. It is equal to 5 multiplied. Now factorial of 4 will be 4 multiplied by factorial of 3. Right? Similarly, 5 multiplied by 4 multiplied by factorial of 3 can be calculated as 3 multiplied by factorial of 2. Right? and 5 multiplied by 4 multiplied by 3 multiplied by factorial of 2 can be calculated as 2 multiplied by factorial of 1. And in the logic we have given factorial of 1 will be 1. So it is nothing but 5 into 4 into 3 into 2 into 1. Right? So this is the logic. This is exactly the same mathematical concept we have presented here in the recursion option. See, so return n multiplied by factorial of n, and this is what we call as, I'm calling the function factorial inside itself. I'm creating the function called factorial. Inside it, I am calling the same function, and that is the concept of recursion, right? So if I show you, Control C, and we go to Python tutor, edit this code quickly. Yeah, right. And result is equal to, yeah. So let's see the execution. So first a function will be created. See, in the global frame called factorial of n, it is created. Next, so result is equal to factorial of 5. So I'm calling a function factorial with the value 5. So n is equal to 5. Next, if n equal to 0 or 1, condition false, so it will come to else. See, else return n multiplied by factorial of n minus 1. That means 5 multiplied by factorial of 4. See, now the next function has been called with the value called 4. I hope you are able to understand. Then next, again 4 is not equal to 0 or 1, so it will come to else. 4 return 4 multiplied by factorial of 3. Next, another function is called factorial with n value 3. Next, another function is called with the factorial value of n2, and then when we call the factorial function with the value 1, it will match this condition line number 3 and the output will be 1. See, came inside the if statement line number 4. Next, and that is how we have calculated the factorial of 5. See, 2 and 120. Right? So 5 multiplied by factorial of 4. Then 4 multiplied by factorial of 3. Then 3 multiplied by factorial of 2. Then 2 multiplied by factorial of 1. And factorial of 1 itself is 1 only. So that's how we have got 120. Right? So just execute this program once or twice more so that we understand it much better. So that is the concept of recursion in Python, right? There are a lot many more examples. If I come to W3 schools, we have this one more example. You can just try it, execute it. If we come to Geeks for Geeks, we might have some more examples. There is a Fibonacci series. I still remember when I was in college, my teacher told me, taught me recursion using Fibonacci series, right? So there are many more options by which we can create, recursion. So just try to do 3-4 more programs as an exercise, and yeah, so that's all about recursion. I will not stretch this video much longer, but I hope you are able to understand the concept of recursion and you will be able to apply whenever needed. Right. So that's all for this video. Thank you so much, and I'll see you in the next video. But yet, yes, if you like this video, if you're able to understand and correlate with the content, please like this video, share it with your friends, and subscribe to the YouTube channel. More than 80% audience do not subscribe the channel. So it is it will be really helpful for us as a teacher to be motivated. So please consider liking, sharing, and subscribing to the channel. Thank you so much.